Class, today we are going on to section 8.2 of your E-Maths, and that is on the area of sector. Now, the area of sector is quite similar to the length of arc, just that we will have x over 360 times area of circle. Okay, so x over 360 times pi r squared. So when we are talking about area of sector, we substitute in area of circle, which is pi r squared. But when we talk about length of arc, then we substitute in the circumference, which is 2 pi r. So that is the only difference. Okay. Now this particular formula is found on page 257 of your textbook. Page 257 of your textbook. Okay. Now I'm going on to example 4 straight away. Okay, example 4 straight away. Now example 4 says that in the figure, O is the center of the circle of radius 26 cm. The length of the minor arc AQB is 52 cm. Show that angle AOB is approximately 114.6 degrees, and hence find the area of the major sector OAPB. Now, first of all, they tell you the length of the minor arc is 52. So, length of arc is x over 360 times 2 pi r. So, 52 is the length of the arc, x over 360 times 2 pi r. Now, my aim is actually to find out the angle that is subtended at the center. If not, we cannot. That is the question asks for angle AOB. Okay, let me rephrase it again. The question asks for angle AOB, which is the angle subtended at the center over here. Okay, so since they tell you the length of the minor arc AQB is 52 cm, so 52 is this. We plug in the formula, and x degrees over 360 degrees, we put over one side and bring everything over. You can find x, which is 114.591. And if we write it out to one decimal place, we will find that it's actually 114.6 degrees. So we have already shown that angle AOB is 114.6 degrees. Okay, now the question says, hence, find the area of the major sector OAPB. Now, if we want to find the area of this sector, we must know this angle. Okay, now we have to take 360 degrees minus 114.591, which will give me 245.409 degrees. Okay, then over 360 times pi r squared, I will get the area of the major sector 1450 cm squared. Now take note that if we want to find the area of the major sector, we got to find this angle. Okay, because this is the major sector, this is the angle subtended at the center. Okay, now as we have in the previous part in 8.1, I want to tell you that this particular formula can actually enable us to find one unknown given the other two. The unknowns are actually area of sector, the angle, and the radius. Now, area of sector, angle, and the radius. Now, given any two of them, we can find the third one. That means if you are given angle and radius, I can find area. If you are given radius and area, I can find angle, and so on and so forth. Okay? Alright, so that will be your example 4 and how we use this formula to find all the various unknowns that is going to be given in the later exercises. Okay? Now, we are moving on to example 5. Now, example 5 looks quite difficult, but actually, if we apply it properly, it is okay. Now, this is the diagram that is given for your question. Okay, that is given for your question. Now, question for example 5 says, in the figure, ABCD is a trapezium in which AD is parallel to BC. Now, AD is 7 cm, BC is 10 cm, and angle ADC, angle BCD is 90 degrees. PXD is an arc of a circle centered at A, and P YC is an arc of a center at B. Show that angle BAD is approximately 100.2 degrees. Now, where is angle BAD? Now, angle BAD is this whole angle here. Okay, is this whole angle here. Now, everybody knows that this is a 90 degrees. Alright, everybody knows that that is a 90 degrees because it's a quadrant. Okay, now, if we can find this little angle, which I'm going to call it theta, okay, and I add on to 90 degrees, I will get the angle BAD. Okay, I will get the angle BAD. Now, according to the diagram, this is 7 and this is 10. So this little side here will be 3. Okay, now one more thing to take note. This is a sector, so if this is 7, this is also 7 because they are radius. This is 10, this will also be 10 because they are radius. So this whole length here, AB, is actually 17 cm. Okay, now if we know the opposite and the hypo, I can use sine to find theta accordingly, and I will get my theta as 10.164 degrees. Now, they are looking for angle BAD, so I'm going to add them up, and I have shown that angle BAD is 100.2 degrees according to the question. Now, part 2, hence find the area of the shaded region. Now, I need you to take note that the area of this shaded region is actually this trapezium minus this sector minus this sector. Okay, now let's take a look at the question. Now, we know that this angle is 100.164. Now, this angle and this angle, with these two lines parallel, they are interior angles. So these two angles will add up to 180 degrees. So angle ABC, which is this angle, will be 180 minus 100.164 interior angles parallel lines. This will give us 79.836. Now, there's another way to get this angle. Okay, note that this is a quadrilateral, and angle sum of a quadrilateral is 360 degrees. If you take 360 degrees minus 90 minus 90 minus 100.164, you will also get a 79.836 degrees. Okay, so I'm able to find this angle and this angle already. So now it leaves us to find what is the height of the trapezium, which is DC. Now note that DC is actually equals to AT over here. Okay, now I'm going to find AT first. Alright, I am going to find out what is AT first. Now I'm going to sketch the diagram here for you. Okay, this is your AT, this is 3 cm, and this is 17 cm. By Pythagoras theorem, I'll be able to get AT as 16.733 cm. Okay, now let's take a look at how we are going to get the area of the shaded region. Okay, now I'm going to do it slowly here. First of all, we go and find the area of trapezium. Area of trapezium will be, okay, just a minute. Area of trapezium will be half times height times sum of parallel sides. So it will be half times this height times the sum of the parallel sides over here. Okay, so I will get an answer 142.23. Now, area of small sector, which means this sector here, I will get this answer 100.164 over 360 times pi r square. I will get this answer that is shown in red, and then I will get the area of the big sector, which is this particular sector, with the angle here as 79.836. I will apply the area formula, okay, and I will get the answer as 69.670. So if I take the area of trapezium minus the two sectors, I will get a 29.7 cm squared. Now, you can find out the areas individually with 5 figures truncate and you minus it off, or alternatively you can just straight away get this, minus this and this, alright, without having to find out the intermediate steps. It is also okay. It's entirely up to you, because the answer will be the same. Okay, just remember that all working must be given to 5-figure truncate, and all answers must be given to 3 figures round off. Okay, that will complete your example 5, that is on page 258. Alright, okay, now I'm going to give you your homework for your exercise 8B now. Alright, now there are 4 questions that are to be done in your notebook, and 5 questions that are to be done on the foolscap paper. Okay, in the notebook you're supposed to do 3C, 4B, 7 part 2, 8. Foolscap is 2C, 5B, 6C, 9 and 10. Okay, now please make sure you know how to do this homework, as these are the essential questions that you must know for your exam. Okay, now after you have done your homework, then you check answer with my video again. Alright, now I'm going on to question 3C of the of your textbook, which you're supposed to do in your notebook. Okay, the question says that the figure shows a circle with center O and angle AOB as theta degrees. The circumference of the circle is 88 cm. Find the length of arc ACB and the area of the sector OACB for each of the following values of theta. Now I will sketch the diagram. Okay, now the question say that this is 126 degrees, and you're supposed to find the length of arc ACB and the area of the sector OACB. First of all, the circumference is 88. Therefore, you can get the radius as 14.005. Okay, applying the circumference formula, 2 pi r is 88. R is 88 over 2 pi. We'll get the radius as this. Now, length of arc is 126 over 360 times 2 pi r. So we'll get this answer. Okay, 30.8 cm. Now, I want to give you an alternative way of doing this. Now, can you see that the length of arc is equals to 126 degrees over 360 degrees times the circumference, which is already given as 88. Alright, which is already given as 88 in the question itself. Okay, so if we key in the calculator with this particular information, you will get the answer as an exact answer 30.8 cm. Now note that both answers will be, both methods are acceptable, because this 2 pi r will ultimately give you the circumference, which is 88. Okay, now next they want to find the area of the sector. Now for the area of the sector, we definitely have to use this radius, because there's no way that we can find the area without the radius. Okay, so area of sector will be, apply the area formula, we'll get the answer to 3 significant figure as 216 cm squared. Okay, so that will be your 3C. Next, we are going on to 4B. Now let's take a look at 4B. What does it say? It says that the figure shows a circle with center O and angle POQ as x degrees. The area of the circle is 3850 cm squared. Find the area of the sector OPSQ and the length of arc PSQ for each of the following values of x. Now let's take a look. They tell you that area of the circle is this. Okay, so I'm going to find out the radius, which I give to 5-figure truncate over here. Now, like what I explained just now, area of sector is actually 84 over 360 times pi r square. You will get an 898 cm squared. Now, all of you also know that area of the circle is given in the question as 3850 cm squared. Okay, so alternatively, we can take 84 over 360 times 3850, which will also give us a 898 cm square. Now both methods are acceptable, just like what I've explained on top there. Now next, we need to find the length of the arc PSQ. Now to find this length, definitely we got to know the radius. Okay, so length of arc, the answer given in green over here will be 84 over 360 times 2 pi r. I plug into the formula all the values, I key in the calculator, I'll get 51.3 degrees. Okay, now I just want to reiterate this point. Okay, now for 3c, it is okay to use 2 pi r, but I want you to note that 2 pi r is actually equals to 88 according to the question. So when you use this method, it is more accurate. I mean, the answer is more accurate. Okay, now for this 4b, you can also use pi r square, it's no problem, but we know that pi r square is already 3850 according to the question. Okay, so when we use this particular method over here, the red one, it will be easier for you to calculate. Okay, so that will be your 4b. Now next, let's take a look at 7 part 2. Now what does 7 part 2 says? Given that OA is R, OC is capital R, and AOB is M, find the parameter and the area of the shaded region A, B, C, D for each of the following cases. Now I'm going to do part 2. Now I'm going to draw this diagram here. This is 5, this is 8, so you follow that this is 3. Now how do I get the parameter of this area? I will have 3 plus 3, that means 3 times 2, plus these two lengths here. So I will have this, the first length, the second length, and I will get the answer as 33.2 cm. Okay, now for area of the shaded region is easier because I just need to take the bigger sector minus the smaller sector. So this is the bigger sector with radius 8, and this is the smaller sector with radius 5. So I will get the answer as 40.8 cm square. Alright, that will complete your question 7 part 2. Next, we are going on to question number 8. Now question number 8 says, in the figure, the area of the shaded sector POQ is 5 over 18 of the whole circle. Okay, so angle POQ over 360 is actually 5 over 18. So I will get POQ as 100 degrees. Okay, POQ as 100 degrees. Alright, because the ratio of the angles will be the same as the ratio of the area. Okay, now let's take a look at part 2. Given that the area of the shaded sector is 385 cm square, find the diameter of the circle. Now area of sector is 5 over 18 times pi r square. Now even if you take 100 over 360, it will still give you 5 over 18. So I'm going to manipulate this, find out the radius, which is this particular answer here. But the question, as you can see, it asks for diameter. So in order to get the diameter, I will have to take the radius times 2. Okay, the radius times 2, so I will get a 42.0 cm. Alright, that will conclude the question for number 8. Okay, next I'm moving on to the homework that is given on the foolscap paper. Okay, let's take a look at the homework that is given on the foolscap paper. Next, we look at question number 2. Question 2C. Alright, question 2C. Okay, what did they ask for in question 2C? They said for each of the following circles, find the perimeter and the area of the minor sector. Now for this case here, the minor sector is here. They want the perimeter, so it's 6 plus 6, the 2 radius, plus the arc length formula, 2 pi r, 140 over 60, you will get a 22.7 cm. Okay, the area is easier, 140 over 360 times pi r square. you will get the final answer as 44.0 cm squared. So that will be your 2C. Next, we are going on to question number 5B. Let's look at question number 5. What does it say first? It says that find the radius of each of the following circles. For 5B, area of the major sector is 369 cm squared. Now, this is the diagram that you must draw for yourself. Okay, you must draw for yourself. Now, they tell you that the area of the major sector is 369. That means it's this big area here. And this angle subtended is 294. We take 360 minus 66. So I will get this area of sector is equal to 369. So r squared is this. R will be square root of this. I will get the radius as 12.0 cm. That will be a 5B. Okay. Next, we are going on to question number 6. Question number 6, they did not draw you a diagram, so it's better for you to draw the diagram yourself. The diameter of a circle is 18 cm. Find the angle subtended by the arc of a sector with each of the following areas. Now, we can just draw a sketch of any sector at all. Okay, this is the angle theta. Now, note that the question said the diameter is 18, therefore the radius is 9. And this sector, okay, has got area 214.5. So theta over 360 times pi r squared will be 214.5. We do the necessary manipulation. We will get the answer as 303.5 degrees. Okay, so it's just applying the formula and substituting in the correct values to get the answer itself. Okay, so that will be your answer to question 6C. Alright, question 6C. Now we are moving on to question number 9. Let's take a look at question number 9. Now question number 9 is quite similar to our 8A, exercise 8A question, but this time around they're asking for area. Now during an art lesson, students are required to make a shape in the form of a sector of a circle of radius 12 cm. If the perimeter of the shape is 38 cm, find the area of the paper used in making the shape. Now, if we know that the perimeter is 38, the radius is 12, we know that the arc length here is 14, because these three lengths must add up to 38. Okay, these three lengths must add up to 38. Now, we will use the length of arc as 14. Okay, the length of arc as 14. We use the length of arc formula, equate it to 14. We find the angle subtended first. Now, once we find the angle subtended at the center, we are able to find the area of the sector. We apply the area formula, we'll get the 84.0 cm squared. So that will complete our question number 9. Okay, now the last question that we have is question number 10. Okay, question number 10 states that the figure shows two circular discs with radii 11 and 7 cm touching each other at R and lying on a straight line MPQN. Show the angle PAB is approximately 77.2 degrees and hence find the area of the shaded region. Okay, now I'm going to show you this question here. Now, if I draw a line here, I call it BC, okay, and this will be a right angled triangle. This is 4 cm. Now, don't forget, this is the radius 7, so BR will also be 7, and RA will be 11 because it's also the radius. So we have adjacent, hypo, we use cosine. We will find that angle PAB is approximately 77.2 degrees. So that's how we get the first part of the question itself. Okay, next question. They say find the area of the shaded region. Now, if you want to find the area of this shaded region, we just need to take the area of this trapezium minus of the area of the big sector minus of the area of the small sector. I'll be left with the green area here. Okay, now before that, let's take a look. Now, I know this angle as 77.160. I need to find this angle here, angle ABQ. Okay, now angle ABQ, I can use angle sum of quadrilateral, which is 360 degrees, to find this remaining angle, because I found this angle earlier. So I will get the angle as 102.84 degrees. Okay, now I am also going to find out the length of BC here using Pythagoras theorem. So I use Pythagoras theorem. I find that BC or CB is equals to 17.549. Okay, now I'm going to apply the formula. This part here gives us the area of the trapezium, half times height times sum of parallel sides. That will be the area of the trapezium. Now this part here is the area of the big sector. This is the area of the small sector. I'm just applying the area formula to find the area of a sector. Now instead of finding the individual cases, I straight away key in the calculator and I will get the answer as 32.5 cm squared. Now if you do not want to do this, you want to give the individual answers to 5-figure truncate and then find the difference, it is also okay. The answer will be the same. Okay, so class, this will complete the whole of exercise 8b, question number 10. Okay, please ensure that you do your homework first before you go through the answers, and if you get the answers wrong, please look at the mistakes that you have made and correct them, and do not repeat it in future. Okay, so that will complete your section 8.2. Thank you, class.